Okay, and now there is actually a third approach that we can take. And to explain why the third approach works, recall that in last week's video, at the end, there was a follow-up question asking, if two positive numbers have a fixed product, the closer in value they are, would their sum also be smaller? So it's asking if this statement here is true. And the answer is yes, absolutely it is true. And there are many ways to confirm that it's true. For example, we can go back to our example, and let's say we have a fixed product of 1,000 and 600, and we have 40 and 40. If our statement is true, 40 and 40 would give us the least possible perimeter. And you can try any other two numbers, let's say, for example, 20 and 80, and you'll find that they add up to more than 40 plus 40. So you can try some examples to confirm it. We can also try to solve it a bit more systematically, although it's still not a proof, which is we can think about the principle which we've already proven, which is that when two numbers have a fixed sum, so the sum stays the same, and their difference decreases, as they get closer in value, then their product increases, right? And here in our case, instead we have a fixed product, so the product stays the same, and we get the value getting closer, and we need to see what the sum does. And here we can say that the sum will decrease, so the difference is decreasing in both cases, so it's the same, so we can take that out and not ignore it. So let's say that when the sum stays the same, the product increases. And if the sum here stays the same, the product is going to increase. If the sum here increases, the two numbers are getting bigger, right? So the product is going to get bigger, even faster. It's still going to get bigger. It's not going to stay the same. So our only choice is to decrease the sum so that the product is naturally trying to increase, because the difference here, the product would be increasing if the sum stayed the same. But because we're making the number smaller, now the product also decreases, and now we have a chance for the product to stay the same. So in order for the product to stay the same, the sum has to decrease. If it stays the same or increases, the product is going to increase. All right, so remember that this statement is true. If two positive numbers have a fixed product, then we need to have them closer in value to make their sum the smallest. Now, if we look at our problem, then the area is a fixed product, right? So here they have a fixed product of 2024. And we want the least possible perimeter, which is twice the sum of the two sides. So we want the least sum, right? So now we can use factorization to find whichever two numbers are the closest, but would still give us 2024. We're trying to find two numbers that multiply to give us 2024, and we want the two numbers to be the closest that we can get. So here's 2024, and here is the prime factorization of 2024. And we want to see how we can arrange the factors so that we get two different numbers multiplied with each other, and the two numbers should be close. Now you notice that 2 times 11 is 22, and 22 and 23 are very close. And now we have two 2's left. So if we distribute each of the 2's, so we give 1 2 to 22 and 1 2 to 23, we get 44 and 46. And this seems to be the best way to make the two numbers almost equal. They're still not equal, but it's as close as we can get. And again, we can check that we can solve that the perimeter would be twice their sum, which would be, in this case, 180. And 180 is B here, so the answer is B. And there you go. We've shown that just by simply knowing that one principle, we've already come up with 3 different approaches to solve this problem. And remember that it is a competition level problem. We can use one of the 3, or you can also use some other method, your own method. It's very quick and it's very easy to solve this problem. And anyway, I hope you've enjoyed, and I hope that at least one of the approaches was new and interesting, and you took something away from this video. If you did, then please like the video, and I'll see you next time for a different problem.